All right, today in Algebra 2, we're going to look at the second half of section 2.6, which dealt with the quadratic formula. Today, we're going to focus on what's called the discriminant. This is going to help us identify the number of solutions and the type of solutions that any quadratic formula or any quadratic equation has. The radicand, and remember that radicand is simply what's underneath your radical in the quadratic formula, is what determines the nature of your roots. Remember, another name for roots are solutions, zeros, x-intercepts. The discriminant of a quadratic equation that's in standard form, ax squared plus bx plus c equals 0, is the value of the radicand, which is simply b squared minus 4ac. So the value of the discriminant, we're going to have three different possibilities. Okay, one is when b squared minus 4ac is less than 0. So this is when it's negative. The next will be b squared minus 4ac equals 0. This is when it's 0. And then our last possibility will be when b squared minus 4ac is greater than 0 or positive. So first let's look at when it is negative. Okay, so this is talking about when we have a negative underneath our radical. Remember, if we have a negative underneath our square root, that negative comes out as an I, and we're dealing with complex imaginary numbers. So the number and type of solutions, we would have two. Sorry about that. We will have two non-real solutions, which means they are imaginary. What the graph of that might look like, something like this is what that would look like. The relation of the graph to the x-axis. If you have two non-real or imaginary answers, solutions, roots, x-intercepts, that means that the graph will never touch or cross the x-axis, which means there are no x-intercepts, okay? No roots, no zeros. Okay? All right, next, if the number underneath the radical is 0, so our discriminant is 0, you will have one real solution. The graph of that might look like this. So what's happening? The graph is touching my x-axis at one spot. So it touches the x-axis at one spot, and that one spot happens to be the vertex of your problem. All right, and then finally, our last option is when the number underneath the radical, okay, our discriminant, is positive, and when that happens, we will have two real solutions. The graph might look something like this. So notice it doesn't matter if the graph opens up or down on any of these. Okay. So one, two real solutions right there, which means that the graph crosses the x-axis twice. So I have two x-intercepts. So let's practice that. So our first example is describe the nature of the solutions for each equation. 16x squared plus 8x plus 1 equals 0. I notice it's already in standard form, set equal to 0, so I can identify my a, b, and c. So a is 16, b is 8, c is 1. So plug that into the formula for the discriminant, which is just what was underneath the radical in the quadratic formula, b squared, so 8 squared, minus 4 times 16 times 1. 8 squared is 64. Negative 4 times 16 is 64. 64, negative 64 times 1 is still negative 64. It's me 0. So this means that this graph or this equation would have one real solution. And that the graph touches the x-axis once at the vertex. All right, let's look at number 2. 2x squared minus 5x plus 6 equals 0. Again, identify a, b, and c. A is 2, b is negative 5, c is 6. Plug those in, so negative 5 squared minus 4 times 2 times 6. Negative 5 squared is 25. Negative 4 times 2 is negative 8. Negative 8 times 6 is negative 48. I see that this number is going to be negative, which means that this would have two non-real solutions, which again means that they are imaginary. So if I have two non-real imaginary solutions, that means that the graph never crosses the x-axis. There are no x-intercepts. All right, let's look to see how this can be helpful in word problems. So interpreting the discriminant. Number 1, Andrea is about to serve and tosses a tennis ball straight up into the air. The height h of the ball in meters at time t in seconds is given by h of t equals negative 5t squared plus 5t plus 2. Will the ball reach a height of 4 meters? Notice it doesn't ask me at what time does the ball reach a height of 4 meters. Okay, so it's not asking me to solve the equation. It's asking me, does the ball reach a height of 4 meters? So I can look at the discriminant and figure out, is it positive or negative or 0, and figure out how many solutions this would have. Okay? So first thing I want to do is plug in 4 for the h, because that's what I want to know. Does it reach a height of 4? So negative 5t squared plus 5t plus 2 equals 4. Now I'm going to get everything on the same side of the equation. So I'm going to move my 4 over. Negative 5t squared plus 5t minus 2 equals 0. And I just want to know how many solutions and what type would this equation have without solving it. So that's where the discriminant comes in handy. So again, I'm going to identify A as negative 5, B is 5, and C is negative 2. I'm going to find out what is my discriminant. So 5 squared minus 4 times negative 5 times negative 2. 5 squared is 25. Negative 4 times negative 5 is positive 20. 20 times negative 2 is negative 40. I see that this is going to be a negative number. Remember, negative number underneath my radical means that I have imaginary, okay, the I comes out, I have an imaginary, so here I have no real solutions. So a height of 4 meters gives this quadratic equation no real solutions. Therefore, I can say the ball does not reach a height of 4 meters. All right. Notice again, I didn't solve it because it didn't ask me at what time. It just asked me, will it happen? Number 2, according to the model of Andrea's serve, will the ball reach a height of 3 meters? So again, I'm going to start out, I'm going to set the equation that they gave to me, negative 5t squared plus 5t plus 2. This time I'm going to set it equal to 3. And I want to know what types of answers would this have. So subtract 3 over, so I get negative 5t squared plus 5t minus 1 equals 0. A is negative 5, B is 5, C is negative 1. So find my discriminant, 5 squared minus 4 times negative 5 times negative 1. So 25. Negative 4 times negative 5 is negative 20. Or sorry, positive 20. Positive 20 times negative 1 is negative 20. This is going to be a positive, which means this would have 2 real solutions. That was equal to 3. So therefore, I can say that the ball reaches a height of 3 meters twice, because we have 2 answers when that equation was equal to 3. So at 2 different times, the ball will reach a height of 3 meters. They didn't ask me what are those times. They didn't ask me to solve it. They just asked, will it happen? All right, so now the last thing we need to look at is using the discriminant to find a particular equation. So what values of b will cause 2x squared plus bx plus 18 equal to 0 to have 1 real solution? Okay. So let's set it equal. So again, find a equals 2, b is what we're looking for, C equals 18. b squared minus 4ac equals 0. This is what I'm wanting to solve. So b squared minus 4 times 2 times 18, when will that equal 0? So b squared, negative 4 times 2 is negative 8. Negative 8 times 18 is negative 144 equals 0. Move my 144 over, so I get b squared equals 144. Take the square root of both sides. I put the square root in the problem, so I have two answers, positive and negative 12. So what does that mean? As long as b is greater than 12 or b is less than 12, I have one real solution. What happens when b is between less than negative 12? Got my negative there. What happens when b is between negative 12 and positive 12? So b between negative 12 and positive 12 would give me my imaginary, my two non-real solutions. Right? So if I wanted two possible equations, so two possible equations, I just need b, okay, greater than or equal to 12 or less than or equal to 12. So this should have been like that. Okay. All right, so I could say 2x squared plus 12x plus 18 equals 0. That would get me one real solution. 2x squared minus 12x plus 18 equals 0 would get me another one solution. Great, so I'm sorry, I was looking at thinking that said two real solutions. Let me just go back and see my two equations here. In order for it to have one real solution, b has to be equal to 12 or equal to negative 12. If b was greater than 12 or b was less than negative 12, I would have two real solutions. b between negative 12 and 12 would be my imaginary solutions. So my two equations to have one real solution are 2x squared plus 12x plus 18 equals 0, 2x squared minus 12x plus 18 equals 0. All right, so now we're going to look at number 2, determine the value or values of b that ensure 5x squared plus bx plus 5 equals 0 has two non-real solutions. So again, I'll look at when would it have one solution, set it equal to 0. So a is 5, b is what we're looking for, c is 5. So b squared minus 4 times 5 equals 0. B squared, negative 4 times 5 is negative 20. Negative 20 times 5, negative 100 equals 0. So b squared equals 100. Take the square root. So when b is positive and negative 10, this would have one real solution. Okay? So that means that if b was greater than 10 or b less than negative 10, it would have two real solutions. b between negative 10 and 10 would have two non-real solutions. So this is what they asked me, non-real. So two possible equations, I could say, let's say 5x squared plus 8x plus 5 equals 0, or 5x squared minus 6x plus 5 equals 0 would get me two non-real. So set the discriminant equal to 0, solve it, that gets you where you're going to have one real solution. The number is bigger than your positive that you get, or smaller than your negative that you get. Those give you your real solutions. numbers in between the two that you get would give you your non-real or your imaginary solutions. So that wraps up section 2.6.